from 1 to 9 of u to the negative 1/2 minus 2u du. The square root of u divided by u is u to the negative 1/2. Negative 2u squared over u is equal to negative 2u. So now you integrate, and what do you get? 2u to the 1/2 minus u squared, and you're evaluating that from 1 to 9. Anybody have an answer for that? Just tell me what it is so I don't have to do the arithmetic. Negative 76. That's correct. Yep. Okay, so what's the next one that you want to see? Next one. What do you want to see next?
12.
Maddie, thank you for raising your hand. Yes. What? 20. Okay, good. Did I call this one out at all when I gave this to you? No. Okay, so when you look at this, what's the first thing you should attempt to do? Maybe. Yeah, can you simplify? What do you think? Nope. There's nothing you can do. There's nothing clever you can do on that one. What might you then recognize next? What might you see? Yeah, what do you think you see? Yeah, you might split it and do something like this. Negative 1 to 1 of 1 over 1 plus x squared times sine x dx, right? And the reason you did that is why? This right here, yes, you're right. The integral of 1 over 1 plus x squared dx is what? Tangent inverse x. And that right there should make you feel as though you're going in the right direction. What's the big problem, though? The sign, right? The sign is, it's not alone. If it was alone, are you done? Yeah, you're done if it was all alone. But is it alone? No, it's not alone. This is a problem. How do you get that sign to be in there? It's not trivial. It's not trivial. So you might try to go back to simplifying. You might think of more trig identities, but then you're still going to hit a wall. What's the last thing you can potentially try to do? Substitution doesn't work, but you could try it. When you substitute, you have to be able to cancel with something. You'd want to cancel out that sine x, which you can't. So what's one other thing you can always do when you're doing an integral? What's one thing you could always look at? You can always graph it. You can always graph it. What does it mean, the integral from negative 1 to 1? What are you actually finding? The area of the pony? Under the curve, right. Area under the curve, right. So what should you take a picture of? Let's take a picture of what this function looks like. It's a cheap trick, but you need to sometimes get to the point. If you have a calculator, use it, please. If you're going to integrate this.
It's going to be L.
It's going to involve what?
ln.
It's going to involve ln, exactly, because if you can't bring the power to 0 or it goes away, right? So this thing is going to be the natural log of something, right? Evaluated from 1 to 2. Do you agree with that? What's going to be inside that natural log? 2 minus 3x, correct? But if you took the derivative, what is the derivative of ln 2 minus 3x? Someone raise their hand and tell me, what is the derivative of ln 2 minus 3x? Yeah. Negative 3 over 2 minus 3x, right? Is there a negative 3 on top of this thing? So what do we have to put on the outside of this? Negative 1/3. Exactly. You have to take care of the result of the chain rule. If you just do ln of 2 minus 3x like this, and you do dx of this, what does that equal? 1 over 2 minus 3x times what? The derivative of this, right? The derivative of that, which is 1 over 2 minus 3x times negative 3. Do we have a negative 3 on top of this thing? So we need to put the negative 3 down in the denominator. So now you evaluate this. You're doing negative 1/3 times ln of negative what? Ln of what? Negative 4, exactly. Minus ln of negative 1. Can someone tell me what the, as they say in France, problème is? You can't, it's negative, so what's negative? You can't take the natural log of a negative number, right? So this, if we've done everything correctly, this thing does not exist. The question is why? So if you want to understand why, again, what does an integral mean? What are you trying to find? The area under the curve. So what should we look at? Let's actually look at the curve. Exactly. Let's look at the actual curve. Just to record. So our mistake was we need to make sure we put the absolute value signs in. That's it. That's it. Okay? So now what do you do? What's your step after you do that? What do you do next? Plug it in. What's another? Substitution. It's called substitute. Now we substitute. So it's the integral of y squared, the square root of what? U. And instead of dy, we write du over 3y squared. Now, what's the magical thing that now happens that's so super important? Y squareds go away. If they don't go away, what do you have to go back to? Pick something else to substitute. Do you know how to integrate something that says like yu du? No. If you have one differential, you need one variable. This is single variable calculus, not multivariable calculus. Yes. What didn't I write in there? There's something that's missing. Yeah, so you can pull the third out, but there's something missing from that integral expression. What did I not write? The limits of integration. Big common mistake. Are the limits of integration still 0 to 2? No. What do they become? 1 to 9. Because u is equal to 1 plus y squared, you're plugging in 0 and 2. 0 into there is 1. 2 into there makes it 9. So what do you end up with? 1/3 the integral of u to the 1/2 from 1 to 9 du. Is that a pretty easy thing to integrate? Yeah, and the reason we make these limit changes is because do we have to substitute back in for y? No, we don't have to substitute anything back in. This integral expression is exactly equal to what we started with. So what's that equal to? 1/3 times 3 minus 1. So it's going to equal to 2/3. This is just straightforward u substitution. The thing that keys it off is, you notice that right there has a power 1 greater than that right there. Does that make sense? Yeah? Kind of, maybe, sort of? We're good? Okay. Let's pause for 1 sec. Can you tell me about that answer? That answer is going to be what? That's going to be negative. That will be negative because the natural log of 3 is greater than the natural log of 2. The natural log of 3 is greater than 1. The natural log of 2 is less than 1. That's going to be negative. So does this actually work out nicely? Yeah, it does work out nicely. Works out really, really nicely. So just remember curves. Finding the area between two curves is no different than finding the area underneath one. You're just going to, instead of having one function, you're going to have two, but you're going to create a new function by doing what? You have those two functions, and what are you going to do? If you want the distance between two things, what do you do? Subtract the one below from the one above. That's it. Does it change anything about integration? No. So when you see this right here, what's the lower limit of integration? What's the upper function? What's the lower function? Okay, so if we actually draw this out, here's if that's our upper function, we'll call that g of x. And if we call, let's say, this function is f of x, we're integrating from x equals a all the way to x equals b. We're finding this area right there. What are some things you have to be careful of if you're finding the area between two functions? What's one thing you think might be a problem or a mistake people make? If I just gave you two functions and said, what's the area enclosed between these two functions, what do you have to be careful of? What's the lower limit of integration in this case? Yeah, 0. And what's the upper limit of integration? 1. What's the upper function? And what's the lower function? And you're also assuming that x stays below e to the x the entire time. Does it? I mean, your immediate reaction is, are you 100% sure either way? Well, for example, what is e to the 0? 1. It spikes up, right? But maybe it goes over and crosses, right? It actually doesn't. You can assume that because it's telling you specifically it's bounded above by that function. But just if you had to sketch this, e to the x is going to start at 1 and go like this. What's y equals x look like? Does it get close to crossing? It depends on how you define close, I guess. Yeah, it doesn't look like it, though, right? The point is, one interesting question would be like, what x value brings it closest, right? That'd be a cool exercise. That's not trivial, everybody. That's not trivial. So are you confident you can integrate that? Yeah, what's the integral of e to the x? E to the x. What's the integral of x? 1/2 x squared. So do you feel as though you could get an answer for that? Good. Let's just write out the other ones. What's the area of the region enclosed by those two parabolas? Let's actually flip that out once so you can get some space here. What's the area enclosed by two parabolas? Oh, I don't know why I did that. Oh, well. We talked about this. What are our two methods of integration? U sub and undoing the power rule. That's it. If you go to BC, you learn 2 or 3 other ways, but in this class, how many do you have? 2. 2, essentially, depending on how you classify them. Okay, so let's take a look at the third one. Third one says, yeah, we can do the third one too. Oh, and I don't know why it does that. So pause it, just because it freaks out. So here's the blue. Here's the blue. What's that one? Cosine x. So how many integrals are we going to have to do? 2. We have to break this thing in half. Well, maybe it's half. So what might we need to find at this point? Where they intersect. Where does sine x equal cosine x for the domain? Remember, it's going from 0 to, sorry, 0 to what? What's the domain of this? We're going from 0 to pi over 2, right? Where does sine equal cosine x? That's when tan x equals 1. So that's when x is equal to pi over 4, right? So what's the first integral we need? 0 to pi over 4 of sine x minus what? Sine x minus what? What's the lower function? What's the lower function? X. No, not x. No. No. What's the lower function? 0. It's bounded by these two. Oh, wait a minute. We're looking at the wrong side. Oh, my bad. Look what the question says. Does this thing say bounded by the x-axis? No, it says bounded by x equals 0, which is which axis? Which axis is that?
Y.
So I'm going to change this for a second. I'm going to change it to this. We did it as y equals 0. So let's finish it like that, okay? So what's the low? It's 0 is the floor, right? What is y equals 0 is the floor, right? We've been doing that every single time, haven't we? But do we usually write minus 0? And what do we add to that? Pi over 4 to what? Pi over 2 of cosine x minus 0. Exactly, right. Minus 0 dx. Can you guys finish that on your own? Sure. Now let's say we changed it, and instead, let's talk about this region right there. Let's talk about this region just right here. Just that one. Or maybe we'll go all the way to here, the yellow region. How many integrals do we need? 2. Do we already have the key information, the intersection point? Yeah. In this case, the integral is going to be the integral from 0 to pi over 4. What's the upper function this time? Cosine x minus sine x dx. And what are we going to add to it? Pi over 4. Don't go anywhere. Pi over 2 of sine x minus cosine x dx. Are those things you can definitely integrate? Yes, absolutely, absolutely, absolutely. In this class,